Hello and welcome back everyone. In part 1 we learned about series, data frames and basic pandas operations, including how to write a CSV file. In this video we will go one step further and learn how to read a CSV file, explore a dataset and handle missing values, all inside Google Colab. So let's get started. Right now I am inside Google Colab notebook, which I have named as Pandas Basics Part 2. Now I am going to show you how to load a CSV file. First of all, we will click on this icon and here we will click on upload button. Then I already have this file called employees. I am going to click on it and this is a CSV file. As you can see, I will open it. And here is a small warning which asks me to save this file elsewhere also. So I'll click on OK. And this file is uploaded as a CSV file, as you can see in this folder. Now before reading a file, don't forget to import pandas. That should be the first step. So I'm importing pandas as PD. Run the cell. And now pandas library is imported into my script. In the next step, I am going to read the CSV file and load it as a data frame. So first of all, we will click on code and then I will name my data frame as df equal to pd.read_csv. This method reads the CSV file which I will get from here. So I will click on employees.csv, click on these three dots and then copy path, and inside a pair of inverted commas I will paste this file path. And after that I am going to run the cell. Now this data frame is loaded. In the next step, let's read the top 5 rows of the data frame. So in order to display the top 5 rows, I am going to pass df.head method inside the print method. This head method reads the top 5 rows of any data frame by default. But here you can pass any value. For example, if I pass here head 10, then the top 10 rows, if exist, then they will be displayed on the screen. By default it displays only the top 5 rows, so I am going to go ahead with the default values, and here we have got the top 5 rows. As you can see, one of the values is NaN, that means not a number. That's because the value might be missing in case of salary for this particular employee. Anyway, we will handle the missing values later on. Moving ahead, we can also display the bottom 5 rows of the data frame using the tail method. So instead of head, if I type tail, then I will get to see the bottom 5 rows. As you can see, the index values range from 3 to 7 this time. We have a total of 8 rows in the actual data frame, and here we have got the bottom 5 rows. So these head and tail methods help us get a quick overview of our data frame. I am going to go back to the head and display the top 5 rows once again. And let's move on and display the shape of the data frame. To get the shape of the data frame, we are going to use the shape property by typing df.shape, and when I run the cell, I get to see 8, 6. That means inside our data frame we have 8 rows and 6 columns. So this shape property helps us know how big is our data frame. Let's move on and explore our data set in more depth. So I am going to use the info method this time. So I will type here print df.info, and this info method is useful because it tells us about how many columns are there, how many non-null entries in each column exist, and what is the data type of each column. So I am going to zoom in a little, and here you can see this is a data frame with 8 entries ranging from 0 to 7. We have a total of 6 columns. These are the column names, and D type indicates the data type for each column. And then we have non-null count, that means how many entries actually are present inside the data set for these particular columns. For the top 4 columns we have 8 entries, but for the second last column we have 6 entries. That's because there might be 2 missing values, and similarly for the last column there might be 1 missing value. So this type of information is useful if your data set is large and consists of many columns. Another important method which is used to understand the data set in more depth is describe method. So I am going to type print df.describe, and this describe method gives us statistical summaries of all numerical columns in the data set. As you can see, there are 3 numerical columns which are EMP-ID, age and salary. EMP-ID is for employee ID and here the count is 8. For age again the count is 8. For salary the count is 6 because as I told you 2 entries might be missing. Then there is mean which gives us average for these columns. STD stands for standard deviation for a particular column. Then we have the minimum value for each column. 25% means that 25% of data is below this value for each column, and similarly 50% gives us the median, and 75% tells us that 75% of the data in each column is below this value. And finally we have the maximum value for each column. Okay guys, let's now learn how to add new columns to our data set. So suppose that I want to add a new column named year of joining. Then I will mention the data frame name followed by the name of the column inside a pair of square brackets like this, and after that I will pass the year of joining for all the employees as a list. I have to pass 8 values because I have 8 entries in my data set. So my first entry goes here, then second, third, fourth, fifth, sixth, seventh and eighth. And now if I run the cell, then this column might be added to the data set. But how to know if it is added or not? For that I will once again print the head of the data frame, and yes, year of joining is added here. Okay, let's also add another column for bonus. So I am going to add a new column called bonus, and this bonus will be calculated as 10% of the salary. So here I will type DF salary. Salary is this column, and I will multiply it with 0.10, that means 10% of the salary. Once again I will display the head of the data frame, run the cell, and yes, bonus column is also added to the data frame. Now let's learn about how to remove a column. Let's suppose that later on I decide that I don't need year of joining, it's useless for me. So in that case we can also remove a column, and in order to do so we will have to type here df.drop, and then we will supply the name of the column that we want to remove, which is year of joining in my case. After that I will type axis equal to 1 because all columns are along axis equal to 1, and then we have in place equal to true. This in place equal to true means make the changes permanent in the data frame. After that once again I will be typing df.head, and I'll run the cell, and this time this column year of joining has been dropped from my data frame. Let's move on and learn about some statistical operations. So the first statistical operation is count function. Now here let's suppose I want to count how many total employees are there in the data set. Then I can print total employees, and after that I will put a comma and type here df, then pass the name column dot count, and this count method gives me the count of total employees. So we have got total 8 employees. Now let's suppose that I want to calculate average salaries for all employees. Then in that case I can use the mean function. So first of all I will have to type average salary, and then I will type df, pass the salary column's name dot mean. This mean function is used to calculate the average of a particular numerical column, and in this case we have got average salary as 50,000. Moving ahead, let's suppose I want to find department wise employee count. Then I will first type here department wise employee count, and then I will type df, pass here department, and this is the column name dot. I will use the value counts method. This value counts method is used to count the frequency of unique values for a particular column, and here we are counting how many times a particular department appears. For example, HR department appears 2 times, that means 2 employees are working. DBA department appears 2 times again. Similarly, IT department also appears 2 times and finance department appears 1 time. So this gives us the count of employees working for a particular department. We can also split our data into groups based on a column and then perform operations like sum, average or count within each group. For this purpose, the group by function can be used. Let's suppose that I want to group employees by department and calculate average salary in each department. Then I can use the group by method like this. First of all, I will type department wise average salaries, put a comma and then mention df dot group by, mention the column name based on which you are splitting the data, and that column for me is department column, and I am going to calculate the average salary for all the departments. So that means I need to mention the salary column first, after that put a dot and then mention the mean function, and after that run the cell. Note that the department column has been passed as a parameter to the group by function, whereas salary column has been passed like a normal column inside a set of square brackets. So we have got average department wise salaries for all the departments, and note that IT department has NaN value, that is because the value for IT department for salary column might be missing. Now let's move on and learn about how to handle missing values. Before handling missing values, let's display the data frame once again. So here is my data frame and we have got all the values displayed on the screen. Now I want to calculate how many columns have missing values. In order to check for missing values in each column, we can type print df dot is null and after that sum. So that means if any value is null or missing, then we can count the sum of all the missing values per column, and here is the result. Employee ID, name, city and age have 0 missing values. Salary has 2 missing values and department has 1 missing value, and similarly bonus also, since it relies on salary column, therefore it has 2 missing values. One way of handling missing values is to drop all the rows with missing values. So let's create a new data frame and call it as df2, and now I am going to type df dot drop na, that means remove all the rows from the original data frame. I have to mention the first parameter here as x is equal to 0, that means I am referring to rows. X is equal to 1 refers to columns, whereas x is equal to 0 refers to rows. Always remember that. Okay, so the next parameter is in place equal to true. If I type in place equal to true, that means I am making changes permanent. If I type in place equal to false, then that means the changes are temporary. Anyway, I am making it as false and print here df2. Let's see whether the rows are dropped or not. Yes, the rows have been dropped. As you can see the indices, we have got 0, 1, 2, 3 is missing, 5 and 6 are missing. So there are no missing values right now in df2. But what about my original data frame? Is it still intact? Let's print it once again. Let's see if the changes have been applied to the original data frame or not. No. Since I mentioned in place equal to false, so no changes have been made to my original data frame and it is still intact. But this method of dropping the rows with missing values is only suitable when your data set is large and has a fewer missing values. Here, in our case, our data set is small, so it is better to replace those missing values with something more meaningful. Our first method of filling missing values is backward filling method. So let me see once again, where do we have missing values? And here is our data frame. So let me just drag it a bit. And here you can see that we have 2 missing values in salary column and 1 in department column. So we can use the backward filling method to replace these missing values with the next value. Let's do it. I am going to type df.bfill, where bfill stands for backward filling method, and if I run this cell, then as you can see all the missing values have been replaced by the next value. Here the department was missing earlier and now it has been replaced with the next value, and same goes for salary. Let me show you another method. So although you can replace all missing values at once with a single line like we did in case of bfill method, but it is better to handle each column separately. So now we are going to handle one column at a time. Once again I am having these empty fields and now I am going to replace these one column at a time. So here we are going to fill the missing department value like this. I am going to type df department dot fill NA, and now I am going to pass here unknown to fill the missing value, because I don't know to which department that employee actually belongs. Even though using bfill method we had replaced that missing value with the next value, but we do not exactly know whether that particular employee belongs to DBA department or some other department. So it is better to fill it with unknown. And to make the changes permanent, as always, we will type in place equal to true. And in the next step, I am going to display my data frame, run the cell, and here you can see that the missing department value has been replaced by unknown. Now we are left with just a few missing numerical values, particularly in salary column. Here we see two missing values, and since bonus column is also dependent on salary column, therefore we have two missing values in bonus column as well. So now what I am going to do, I will replace the missing values in salary column with average salary, and then I will recalculate the bonus as 10% of salary. So let's do it. I will click on code and let me scroll up a bit. Here I will calculate the average salary as avg underscore sal, this is the name of the variable, equal to df salary dot mean. So we are saving the average salary in a variable called avg sal, and in the next line I am going to type df salary dot fill NA, and then we pass here avg underscore sal and set in place equal to true, and after that we are going to print our data frame, run the cell. So here there are no missing values in case of salary column now, and as mentioned we have replaced all the missing values of salary column with average salaries. But there is a small future warning over here which says that the behavior of this fill NA method will change in Pandas 3.0 version. You don't need to worry about it right now. So this method is working fine, and in the next step we are going to recalculate the bonus as df bonus equal to df salary, just pass the name of the column, multiply it with 0.10 which is the 10% of salary, and then after that we will print the data frame once again. And now there are no missing values in bonus column as well. So that means the data set is now clean and ready for saving or for further analysis. So I am going to save my data frame, and for that you already know what to do. I will type here df.to underscore csv, and after that give your data set a name. So let's call it as employees underscore cleaned underscore data set, and after that .csv, and I am mentioning index equal to false. I don't want the index to start from 0, and after that run the cell, and now this employees clean data set is created. If I double click on it, then there are no missing values, and we also have the added bonus column which was not present in our original data set. So here there was no bonus column, and now if you want you can download it by clicking on these three dots and then click on download, and your data set is now downloaded on the system, and here you go. And that's all for this video. And that's a wrap of my two-part series on Pandas basics. Today we learned how to load and read a CSV file, how to explore a data set using info, describe and head methods, perform basic statistical operations, handle missing values, and add and remove columns. If you found this video helpful, then don't forget to like, share and comment on this video and subscribe Programming Horizons for more interesting tutorials. I'll see you soon in my next video.